This is the Illinois Nutrient Loss Reduction Strategy Podcast, Episode 41. Are these tools in your toolbox? Bioreactors. I'm Illinois Extension's Todd Gleason. Today, we'll talk about bioreactors, how they're constructed, what they cost, and what benefits they have. Dr. Reed Christensen starts us off. He's a research assistant professor of crop sciences here on the Urbana-Champaign campus of the University of Illinois. I asked him what he does and why he does it.
And I do water. I am really interested in how land management impacts water quality. So whether we're tilling, no tilling, fertilizer application rates, or even moving into the urban arena and what we're doing on the urban landscape, I'm interested in all of that and how that impacts our water.
Very cool. Today, however, we're going to talk about bioreactors. What are those exactly?
Well, in the agricultural setting, bioreactors are also known as wood chip bioreactors, and they're really just a hole in the ground filled with wood chips that receives water from a tile drainage system or a subsurface drainage system from a field, and they are for water quality.
What kind of research is the U of I doing with these?
We're doing lots of fun research. I mean, the list is almost endless, but we're looking at different shapes, different sizes. We're looking at extending the water flow path within a bioreactor by adding baffles. We're looking at different types of wood chips. We're looking at compaction of those wood chips. We're looking at all kinds of things related to configurations of those bioreactors. We're also even looking at how long those bioreactors are in relation to how wide they are, which is a really interesting piece of research.
Well, tell me a little bit more about that. Does it make very much difference in terms of the area that they cover and what they're able to do? Yes,
the answer is absolutely yes. There's a balance between how much water we can get into a bioreactor and how much or how well that bioreactor treats the water. So bioreactors are set up to not treat every drop of water. We're taking what's given to us, and sometimes during the year it's too much, so that water bypasses. And if we make those bioreactors wider, we can treat more of the water, but then typically we don't treat it as well, or we don't keep it in the bioreactor as long, so the nitrate concentrations aren't reduced as much. But yeah, that's a really important, I guess, research topic for us on the bioreactor front.
And if you make it longer?
Well, we make it longer, the water stays in there for a much longer period of time, which is good to reduce nitrate concentrations, but sometimes we can't treat as much water. So more water might bypass the bioreactor than actually get routed in for treatment. So again, it's kind of a balance, and we're really looking to optimize that balance right now.
In general, and you discussed this just a little bit, but are these very good at reducing nutrient losses from agricultural fields?
They are, and that's where that balance is going to come back into play here on this answer. But if we look at just the bioreactor by itself, so all of the water that gets pushed into a bioreactor, we can have nitrate concentration reductions from anywhere from 40 to 80, maybe even into 90% of that nitrate gets reduced, sometimes even 100%. But if we can't treat every drop of water from the field, that means we're bypassing water. When we connect those two pipes at the end after the bioreactor, that's the value that we really care about. And that value, the value downstream of the bioreactor, is in the long-term average is about 25% less than the nitrate concentrations upstream of the bioreactor. So very general rule would be a 25% nitrate-nitrogen reduction from bioreactors, and that's a combined reduction, including any water that bypasses.
Have you looked to see what difference it makes if they're used in combination with other conservation practices? And I'll start with some things that are larger rather than smaller, for instance, cover crops or a grassy area, catchment basement of some sort ahead of the bioreactor or after.
You are asking great questions. So that combination effect or the impact of multiple conservation practices for a given area is really a big gap in our knowledge right now. We don't know how they react together. We can assume, or we can make assumptions, and there are some studies underway trying to quantify those. But basically the edge of field practices like a bioreactor, they take whatever you give them. So if you reduce nitrate leaving your field the bioreactor is going to have less to treat, but it's probably going to function at about the same efficiency. So if you're giving it half the amount of nitrate, it's still going to reduce that by 25%, but we're just starting at a different place. So those combination practices, I think, are going to be up and coming area of study across agriculture for many different practices and many different types of landscapes.
A couple of things. If farmers are interested in this, should they contact you? How should they do that? What's the typical cost of a bioreactor, and what's the construction like?
Well, I think the best place to start, if you wanted to do a bioreactor, would be the USDA Natural Resources Conservation Service, or the NRCS. They can do that design for you, and if you're working under a USDA program, then there's even, obviously money available for helping to put that in. But typical costs probably range from, hover around that $10,000 mark, so $10,000 to maybe $15,000, depending on how big of an area you're treating. And a good chunk of that cost comes in the form of the wood chips that you need to purchase to put into it. We've done research kind of across the board looking at different types of wood chips, but we really see high quality large wood chips, in the realm of 2 to 3 inches in diameter. Those are the best, and especially if those don't have any fine materials like any type of debris from the chipping process. If that's been filtered out, those wood chips are going to last longer and perform better, but they also cost quite a bit more. So it comes back to that balance, and depending on when or how long you kind of want that bioreactor to last versus that upfront cost.
How long will the wood chips last in the bioreactor?
That's another great question. We're kind of reaching the point now where we have bioreactors that have finally reached the end of their life, and we're starting to replace wood chips. And I think the initial estimates were, maybe that 10-year mark is a good mark. They'll last about 10 years, and then you'll dig the wood chips up and put new wood chips in. And maybe some of the wood chips we've seen, the poorer quality wood chips may be lasting 7 years, and the higher quality wood chips we still haven't replaced after maybe 10 years. So that 10-year mark was probably a good estimate from the start. So I'm going to keep with that 10-year mark.
Are there other things that need to upkeep, and what does that entail?
Yeah, there's actually very little to do with most of these bioreactors. They're an edge of field practice, and they can be set up to set them and then forget about them. But if there is a management component, it would be to potentially relieve or move up or let all the water drain out during the summer months when there isn't much water flowing anyway. And then that'll just basically dry that bioreactor out and let those wood chips dry out a little bit. But it also help with sulfur reduction. That's one of the one of the drawbacks of a bioreactor is if they stay saturated and there's no water moving through. If there's stagnant water, then you get rid of all the nitrate and you start to reduce sulfate. So then you get this little a funny sulfur smell coming from them. So that's why we typically put in a drawdown plate or a little upside down V at the very bottom of those bioreactors to help them drain out over the long term. But if you don't have one of those, you'd pull the plate out so you could draw down or dry that bioreactor out when it's kind of dry during the end of the summer.
Any advice for farmers or landowners that are interested in installing one of these?
Do a little bit of research, but I think reaching out to NRCS would be the first step and the best step. They can not only get you up to speed on what a bioreactor is, they can help you with the design. They probably even help you select a location on the farm because obviously you need to tap into a subsurface tile drainage system to put one of these in.
That was Reed Christensen. He's a research assistant professor in crop sciences at the University of Illinois. He works with Brian Maxwell, who is a postdoc in the Department of Crop Sciences, also at the U of I. I asked Brian to tell me a little bit about himself, and we moved to Brian because he's done some of this installation work.
Yeah, so my name is Brian Maxwell. I'm originally from North Carolina. That's where I grew up and where I went to graduate school at North Carolina State University in Raleigh. I did my PhD in conservation practices, kind of specifically wood chip bioreactors, which kind of is what brought me up here for about a year after grad school. I was working in Spain at a research university over there, also doing work with wood chip bioreactors, and that kind of indirectly brought me to U of I in Champaign-Urbana, where I'm working as a postdoc in the crop sciences department here with Dr. Laura Christensen and the group. It's a Illinois Drainage Research Outreach Program. So we do a lot of research and extension work with just various conservation practices.
It sounds as if you have a great deal of experience, I would suspect, maybe even in installing a bioreactor.
Yeah, I have more recently. So that was kind of the first experience I had recently on the farm up in Hillsdale, Illinois. That was the first bioreactor that I got put in charge of doing the design for. So I got to kind of oversee that construction and see how that get put in. So it was a pretty cool experience being involved with that.
What are the site requirements for a bioreactor?
So there's a couple different site requirements. They're not, the site requirements, aren't as maybe stringent as, some of these other practices that have kind of soil type and land slope requirements. But, you do want to have, one of the requirements is that bioreactors really aren't intended to treat subsurface drains that are catching a lot of surface runoff. A lot of times that surface runoff can have a lot of erosion from soil in it, and that stuff can kind of clog the bioreactor pretty quickly. You would probably want, if you're thinking about putting in a wood chip bioreactor, you'd probably want some space on your land where you can set aside enough room for it. These things are usually about 10 to 15 feet wide and maybe 40 to 50 feet long, so you'd want to be able to set aside that much space for one, where you're not going to be growing any crops or driving around any heavy equipment, because you're really not supposed to drive over the tops of bioreactors with that. You'll end up kind of compacting the bed. And you also are kind of generally going to want to know where your tile drain system is, where it's laid out, because these bioreactors tie into that existing tile drain system. Sometimes we have farmers who aren't totally aware of where that tile drain system is because it was put in so long ago, and so having an idea of where those lines are can help tie that bioreactor in during the construction process.
After a landowner decides to install the bioreactor, what's the typical timeline for it to be designed and built?
So that's a great question, and that's something we're trying to figure out ourselves, just from having more conversations with farmers who are put them in. Typically, if you're putting one in and you're not working through a university or some other program, through a different grant program to get this installed, you might be going through the NRCS cost share program, which is what a lot of private farmers do. And from what I've heard from various people I've had conversations with, is that it normally takes about a year to put that in, because there's a bunch of different steps in it. The first step is contacting your local NRCS or Soil Water Conservation District office and having a rep come out to your farm and see if it's a suitable place for putting in a bioreactor. So they might do some surveys of elevations, look at your tile maps, and see if the bioreactor is a good fit. And if it is, then the NRCS will actually do the design for it, and then they'll do that for free. So that process might take, depending on their work. And after that, they'll come back to you with the designs, and then it's up to you to kind of find a contractor who's available and who can do that work, and kind of working out a timeline that meets both your schedule with the contractor to come out and put it in. And from what I've gathered, that whole process ends up taking close to about a year.
You mentioned that in the research you've been doing, you were charged with installing the bioreactor near Hillsdale, which is in Rock Island County, Illinois. This one's not typical, I take it.
That was not typical. There were a couple of interesting things we did with it. So because this one was not an NRCS designed bioreactor, we had a little bit more flexibility with the design. A lot of conventionally designed NRCS bioreactors tend to be long and narrow, and a lot of that is for good reason, to get the appropriate hydraulic residence time in that bioreactor, and that determines how much nitrate removal you get. But this was kind of a different, interesting site. It was a pretty large site, and part of the drainage area, I think it drained about 30 acres. Part of that drainage area included some runoff from an interstate on the north end of the drainage area. So we expected that water coming in to be pretty flashy with some of that runoff from the highway. So what we wanted to do is have a more of a wider design than a longer one. With wider bioreactors, you are able to catch more of your peak flow because it's a wider cross-sectional area coming in. You can kind of think of a wider pipe being able to pass more water. So with that wider bioreactor, it should be able to catch more of that water coming in. It was also, looking down on it, it would be a trapezoidal shape for the bioreactor, which is pretty not typical. But one of the reasons we did that was that plot that farmer had, that kind of parcel was wedge-shaped, and he was actually still looking to put some crops down that field. So we wanted to push the bioreactor as far to the south end of that parcel as we could. So that was why the bioreactor also kind of ended up being wedge-shaped to move that as much out of his way as possible. So it'll be interesting. We're going to be doing some monitoring on it as it goes on. We're going to be monitoring how much water it's capturing, how much of the tile flow it's actually capturing, and then looking at how much nitrate it's actually removing. So we'll be able to look at how this kind of unconventional design, how well that's working out there.
Any advice for producers or landowners that are interested in installing a bioreactor on their property?
Yeah, you should definitely, if you are concerned about not knowing enough about one, reach out to a local extension office or soil water conservation district or NRCS office. Talking to them, these people are more than happy to come out and help you learn more about it, how it works, and whether or not it'd be a good fit for your property. And just, being upfront about which bioreactor might mean for your farm. It is a upfront cost for putting it in. And as far as conservation practice, it's not like in-field management practices where there might be some return on it. This is kind of an upfront cost. But one of the good things about edge-of-field conservation practices is that once you put it in, it's really doing its job year in and year out without you needing to spend more time and energy on it. It's going to be removing nitrate for the next 8 to 10 years. That's about the lifespan of these bioreactors. So once it gets put in, it's really doing its job of reducing nitrogen coming off the farm versus maybe an in-field management practice like nitrogen management or cover crops where you might need to be doing something year in and year out.
That was Brian Maxwell. He's a PhD student at the University of Illinois. Now, the site he is talking about belongs to farmer Drew Honenboken, who is in Rock Island County, Illinois. I called him and asked him to tell me a little bit about himself, his operation, and then about this bioreactor.
I am a fifth-generation farmer, and I farm in Rock Island County, which is in northwest Illinois, the northern end of the county. We're split in half, so to speak, with the Quad Cities in the middle. We are we're only a mile away from the Rock River, so I've got a lot of bottom ground. Corn and soybeans. That's basically everything about me.
What conservation practices do you currently use?
Well, I use no-till, have some waterways. I use filter strips, wetlands. I also have some CRP with 24 acres of trees. I have a windbreak that I was planted in when I was 12 years old. I planted it for a 4-H project, and it's 50 years ago. So
That must be so very gratifying. Why is it, by the way, that you're interested, in this case, in a bioreactor?
it's important to have good water quality. It's important for every aspect of life, like farming, for health, public health, because water is essential to people who live. And also, it's one of the elements that keeps this country, keeps us going. Good water quality.
Why'd you choose the specific site for the bioreactor?
It's close to the waterway, and we have a tile line in the waterway, so they're using the tile line for the reactor. It's by the waterway, which drains probably 30 acres, but it starts right next to the Interstate 88, so we're taking all the water off the interstate. They have the ditches aligned in a way that it comes down the waterway.
Did you use cost share to put the bioreactor in?
Yes, I did. With the cost share with the University of Illinois.
What were your costs like in percentage or otherwise?
Minimal. How's that sound?
That sounds perfectly fine. Any advice for producers who are interested in installing this or other kinds of conservation, hard conservation practices?
Test your nitrate levels first. See if it's practical, if it's useful for you.
Well, that's good advice from Drew Hohenboken. He's a farmer from Rock Island County, Illinois. You've been listening, of course, to the Illinois Nutrient Loss Reduction Podcast. This is episode 41. Are these tools in your toolbox? Bioreactors. The program was produced in conjunction with Illinois Extension Watershed Outreach Associates, Jennifer Jones and Rachel Curry. I'm Illinois Extension's Todd Gleason.